En este día vamos a comentar algunos aspectos de geotecnia aplicada a excavaciones confinadas por otras edificaciones, en espacios limitados por otro tipo de edificios, todo en zonas de alto valor comercial. La opción más práctica en términos de costo sería un muro anclado, bien sea con anclaje pasivo o con anclaje activo, mediante anclajes perforados hacia una zona estable de terreno, fuera del plano de falla. La dificultad con este sistema es que los anclajes invaden las zonas aledañas al muro. No es problema si se está estabilizando un talud hacia adentro de la propiedad, pero sí es una invasión a una propiedad colindante si se estabiliza hacia afuera o hacia la calle. Por tal motivo es bueno analizar otras opciones menos o no invasivas.
Secant pile walls are used to construct earth retention walls. Because these piles are cut into each other, they form a continuous wall, which can reduce water inflow into the excavation in front of the wall, as well as retaining the soil behind the wall. Secant piles can be constructed using board cast in place or continuous flight auger methods, cased or conventional CFA. First, a shallow guide wall has to be built. This guide wall is shaped to locate the piles to the tight tolerances, ensuring that the overcut from one pile into another is as required by the wall design. The guide wall is constructed from reinforced concrete. Often polystyrene or timber void formers are used to obtain the scalloped shape of the inner face of the guide walls. Once the guide wall has developed sufficient strength, the piles are constructed through it. The wall can be made from alternating soft and hard piles, in which case the soft pile is usually unreinforced, or from alternating full-strength piles, in which case both male and female piles may be reinforced. First, the primary, or female piles, are drilled into the required depth. Generally, these piles are constructed in a hit-and-miss sequence in order to ensure the adjacent piles are not damaged by drilling nearby until the low-strength concrete is set. After allowing sufficient curing time, the remaining primary piles are constructed. Careful attention must be given to the concrete mix used in primary piles to ensure it has sufficient strength when the secondary piles are cut into it, but gain strength after that with continued curing. Once sufficient primary piles have been constructed, the secondary or male piles are then drilled between adjacent primary piles. The secondary pile is cut into or secanted into the two primary piles either side of it. By careful control of the verticality tolerance when drilling, it's ensured that the overlap between primary and secondary piles remains intact, down to the other side of the deepest excavation level. Subsequent secondary piles are then constructed, forming a continuous retaining wall. Secant pile walls are often used for basement construction, or to form cuttings into existing slopes or embankments. When the area inside of the wall is excavated, temporary support in the form of wailers and struts.
Esta es la opción utilizada en los canales abiertos excavados para pasos a desnivel en Tegucigalpa. No son túneles, son canales abiertos. Básicamente esta es una barrera de pilotes en voladizo, algo muy similar a un tabla estacado, funcionando completamente en voladizo. En el caso de Tegucigalpa se optó por una variante del muro secante. Se trata de un muro semisecante, ya que no hay contacto entre los pilotes, lo cual pudo hacerse al encontrarse en la ciudad suelo arcilloso cohesivo, lutita consolidada o toba, en la mayor parte de los sitios donde se construyeron estas edificaciones. Desde luego hay que contar con maquinaria adecuada para este trabajo. Los pilotes pueden variar entre 60 a 80 centímetros, hasta 1 metro, sólidamente armados, eso sí, para contrarrestar el voladizo. Y también funcionarían como pilotes de punta en caso de tener que sostener cargas verticales. El colado puede hacerse con un tubo TREMI o con una bomba telescópica, a fin de no tener una caída de concreto excesiva que, como ya saben, causa segregación. Esta técnica se podría aplicar perfectamente a sótanos en edificios, ya que no es invasiva hacia las propiedades aledañas.
The construction methodology and excavation options for a diaphragm wall are explained in the following sequences. A shallow guide wall is constructed first along the alignment of the proposed wall. The guide wall serves to locate the excavation equipment within acceptable tolerances before the retaining wall construction commences. The guide wall is made from reinforced concrete, typically 1 to 1.5 meters deep. Walls are constructed to tight verticality tolerance. Excavation of the diaphragm wall is carried out in panels. A typical panel is excavated in 3 bites: a left bite, a right bite, and lastly, removal of the middle dumpling. Bite widths depend on the grab type being used, but 2 to 2.8 meters wide is typical. At the same time as the soil is removed from the panel, bentonite mud is pumped into the excavation to support the surrounding soil, preventing collapse into the excavated trench. Excavation continues until the bite reaches the designed depth. Bentonite mud, or in appropriate circumstances polymer, is batched in an on-site plant, allowed to hydrate to gain full gelling properties, and is then used for temporary excavation support. Typically, bentonite powder in bulk or bagged form is added to water and rapidly mixed in a colloidal mixer to produce the desired concentration of bentonite mud. The mud is usually pumped to a storage tank where it hydrates for up to 12 hours. The bentonite particles swell and absorb the water before it's used to support the excavation. When required, the hydrated mud or recycled mud, or a mix of the two, is pumped to the excavation trench to replace the excavated soil, maintaining a constant head of the mud above the prevailing groundwater levels. Excavation of the panel continues, generally completing left and right bites before removing the centre bite. Then the centre bite is excavated down to the required panel toe level. Steel or precast concrete stop ends are placed at the edges of the excavated panel. The stop end may contain a rubber water bar that later becomes embedded into the concrete. The water bar minimizes water ingress between panel joints once the earth is excavated inside the diaphragm wall. A prefabricated reinforcement cage is then lowered into the excavation between the stop ends. Blockouts for floor slab connections, ground anchors, or other penetrations can be formed in the reinforcement cage. Concrete is poured into the excavation using the Tremie method. This is achieved by use of a hopper and steel tube, extending to the base of the excavation. Typically, 2 hoppers are used for a 6-meter wide panel. The hoppers and tubes are charged with concrete. Then the tubes are lifted off the bottom of the excavation so that the concrete flows out, displacing the lighter bentonite mud upwards. The bentonite is pumped back to the recycling plant as it's displaced. As the concrete level rises in the panel, the Tremie tube lengths are shortened to ensure that fresh concrete is always closest to the concrete bentonite interface. When the concrete rises to the required level, the Tremie pipes are removed and the concrete is allowed to set. The first panel constructed in a run of wall is called the primary panel. During concreting, the excavation grab and base crane is moved to another location, a safe distance from the concreted panel, and excavation recommenced on another primary panel. The next excavated panel is completed and concreted in the same procedure as just described. Subsequent panels excavated adjacent to a completed panel are called secondary or running panels. The final panel concreted in a run of wall is termed the closing panel, as this panel closes up the length of wall. The stop end is removed from one panel during excavation of the adjacent panel. Diaphragm wall panels can be excavated using several types of equipment, including hydraulic cutters. These are powerful machines capable of excavating into hard rock, but require large bentonite plants and large cranes to hold the cutter. Steering mechanisms are built into the grab body to provide a high degree of verticality control. The hydraulic grab. This type of grab has hydraulically operated closing jaws, and so is able to exert considerable closing force to excavate dense sands, stiff clay, or weak rock material. These grab bodies can also include steering mechanisms. The cable grab. This grab uses only pulley forces to close the grab jaws, and so is more suited to softer ground. and the Kelly grab. This grab type is rigidly suspended from the base machine, whereas the 3 previous types are rope suspended. The Kelly grab can provide reasonable excavation force and verticality control, but may not be as fast as suspended grab excavation. Typical diaphragm wall widths are 600 mm, 800 mm, 1200 mm, and 1500 mm, though other sizes can be used for special requirements.
Sin embargo, la opción altamente técnica es un muro diafragma, un sistema complejo y carísimo, obviamente. Solo es viable en centros urbanos de muy alta plusvalía y donde el precio del terreno es extraordinario. Se necesita maquinaria especializada, el uso de bentonita para sostener el relleno mientras se cuela. El concreto, a medida va llegando a la sección final, va desplazando el fluido de bentonita, y ese puede tener un reuso. Obviamente no se trata de muros pequeños, 80 centímetros hasta 150 centímetros, dependiendo de la resistencia al voladizo requerida. Pero en una ciudad con muy alto valor de tierra, vale la pena el costo con tal de poder construir en una zona de muy alta plusvalía. Los armados también son significativos. Se diseña como una pantalla en voladizo, tal como aparece en los libros de texto, con una relación entre la parte en voladizo y la parte enterrada de 1 a 1.5 por lo general. Que se sepa, este método nunca se ha aplicado en Honduras, pero es posible llegue un momento que algunas zonas de las ciudades alcancen tal valor que justifique el tipo de inversión colosal en este caso. Pero, sin importar el tamaño, lo importante es conocer y estudiar la teoría de diseño para tener ingenieros capacitados cuando llegue el momento.